Okay, hey YouTube, Sam here for 42 Maths. So we're going to be looking at, is the square root of 2 rational? So let's assume that the square root of 2 can be written as a over b, with a and b in lowest terms. Okay, so if we assume that it can be written as a over b, what we can do is square it. Square of the square root of 2 is 2, and you get a squared over b squared on the right hand side. So if we multiply through by b squared, we get 2b squared equals a squared. So since b is just a number, two lots of b squared will be even. A is the square root of that. Now, if the square of a is even, a must be even. Okay, so we can conclude that a is even. So a can be written as 2m, where m is some number. So let's look at the original equation. Square root 2 squared equals, so a squared over b squared, so a is 2m. So we'll do the same thing, we'll square it again. So 2 equals 4m squared over b squared. So 2b squared equals 4m squared. And that means b squared equals 2m squared. So now, if the square of b is even, that means b must be even. Because it's two lots of something. So therefore, a and b are even. And what that means, well, it's a contradiction. This is a contradiction because a over b was, or needs to be, in lowest terms. So what we've seen is that if we assume that the square root of 2 can be written as a over b, it leads to a contradiction. So therefore, square root of 2 does not equal a over b. That means that the square root of 2 is irrational. So it's a whole nother kind of number, an irrational number, and there was an ancient Greek who first discovered irrational numbers, and he was killed for it, I think, because by the Pythagoreans, because it was so strange to them that there could be any type of number that wasn't rational. Yeah, okay.